loss. I might call it an end to the stream because of the fact that it's just raining so much. I was kind of hoping to get this done first. We're so close. Ooh. So yeah, what it's doing here is it compiled these. I've noticed here that it compiled this into just one line here. So let's see here. It is taking the image, resizing it. It is then converting it to bytes, providing the size, and then the mode, and then displaying it. I'm guessing mode will be the RGBA. It's that mode. RGBA, that. Why it's converting it to bytes. High game image from shrink. Let's go to over here. Let's see here. Let's go with high game dot. Let's see, what was it using? Image? Yeah, pygame. Oh, wait. Yeah, pygame.image. Pygame.image. There it is. There it is. Load an image from a file. Okay. Save an image. Get it from a bit buffer. Extend the bits. Save extended. Load extended. The image module can... Alright. Yeah, this is to open up the variety of different files. Yes, yes. I'm actually more interested in... Oh, here we go. RGBA. Ooh, nice. They have RGBA. Oh, we should totally get rid of our background. Oh, yeah, we should totally get rid of the background. Let's see here. We currently set the default to RGB, correct? Yeah, here it is, RGB. We're going to set this back to A. Oh yeah, RGBA. Let's see, where's background color? Background color is set to none here. Oh. I think that might be in the sequencer, isn't it? Yep, right here, background color. Background color, we're going to change this to 0 and this to 255. There we go. Making a nice alpha channel background. That should solve that problem, so we should be outputting RGBA now. So we have our frame, which is an image file, and we just need to upload it to Pygame from our good friend ChatGPT. It's saying what we should do is we should Pygame image from string, because we're going to be converting our image to bytes. I'm curious. Let's actually just type in Pygame pillow to image. Yeah, here we go. What do you... Yeah, you're saying to bits. All right, then. Oh, I see. So it's because we need to convert it to a surface. Got it. Sadly, the accepted answer doesn't work anymore because image.toString has been removed. It has been replaced with 2 bits. The function is to convert a pill image to a PySurface object. It is recommended to convert the surface to have the same pixel format as the display surface. See, this is good code. This is what you want from ChatGPT. Something like this. Come on, ChatGPT. Give me something like... Be smarter. Generate code like this. This is a good example. All right then, so payload to surface, image from string. So pi image from string. So this is just his basic function, and he's running convert. Okay. And then we initialize the game. We then generate the clock. Then the pill image is, so here we open the image. We then image to surface. There we go. And then while we run, there's our clock. We're setting to 60 frames per second. For an event, when it clicks quit, we then drop out. We're going to fill window with fill lit with zeros, and then we'll be lit. Pi game surface, hit rectangle, and then we do that, and then we flip. I see. All right. And this is an even simpler version, but this is using toString, which was apparently removed. When was this answer generated? 2020. So it's... Yeah, so... Yeah, that means we're definitely going to have to focus on this. Alright, so Pygame image from string. We're going to do pill image 2 bits, the size, and then the mode. Yeah, this also makes a lot more sense too. Okay, I think I know what we're doing. So the main thing is this right here. We'll copy this, paste it here. Oh, paste. This happens to be frame, and frame. There we go. Because the frame is our image. Boom. Oh, what are you complaining about? Expected type sequence got a tuple with 2 ints instead. And then mode, frame does not have function mode. Wait a minute, I thought that's... But this is a pill image. I wonder if some more stuff has changed. Either way, the last thing we want to do is this. We already have window. We want to then put this on our surface, like so. I'm curious. Window fill 0. I bet the fill 0 is to blanket. That would be understandable, because if you have alpha channel, you're going to get a lot of overlap. Alright then, so what we'll do here is we'll put this here. We'll need to grab the window from here. So let's go ahead and get the window. Dot game components. Dot get, and this will be self dot game display. There's our window. There we go, and then Pi surface happens to just be... It happens to be this. There we go. Okay then. Okay, I think this might be it. So what I've done here is we've added in window get display so we can see what we have. From here we then will take our frame, we'll convert it to a surface. We'll then fill in the window to make sure that there's no residue. Then we will apply this to our surface. They have a center right here. We should probably take a quick peek at the example code. Here we go. They set the display to 50 by 50. So in this case, what we'll want to do is we'll want to take the width and the height and divide it by 2. So let's go ahead and do that. So self dot, there it is, window size. There we go. And then this one right here will be 1. There we go. Perfect. All right, let's run this and see how it works. It kind of worked. I don't see any frames. I don't see any, Oh, not responding. Oh, no. There we go. Okay. Okay. And it crashed. All right. I think that might be the problem. Okay, let's, I think that might be the problem. Okay, let's rerun this. There we go. And we got an error. Okay, why did we get an error? NumPy array has no emit mode. Okay, wait a minute. Wait a minute. Okay, what we're going to do is... Alright, what we're going to do is we're going to change this. Yeah, it's probably because of the fact that we're returning an actual... Oh. Yeah, that's actually a problem. That is a problem right there. We go... I forgot. We should probably return the warp. Like this. There we go. Okay, let's try this again. Oh, it's working. It's working. He's on a black background. I think that's fine. That's fine. 1. Hold 1. Hey, it's kind of working. It's 2. Hold 2. 2. Hold 2. I'm holding 2. It's kind of working. It's kind of working. I mean, it's messing up, but we're getting there. Okay, quit. Oh, there we go. Okay. It's kind of working. It's kind of working. We need to set the tick speed. Okay, then. Yeah, we need to set the tick speed. I don't know how fast it's currently set. Let's see here. We need to add in more constants. So another constant is going to be tick rate. Or tick speed. There you go, tick speed. This is an int. This is a constant. This is 24. Okay, so where's clock? We set clock right here. Okay. So I'm going to first do this. We're going to... Right there. We'll call you clock. Clock. And then clock dot... let's see here. Tick self dot tick speed. Oh. That needs to be capitalized because it's constant. There we go, tick speed. And then we'll store clock. Okay. And what does clock happen to be? What is this? What is your type? You are a pi time clock. Okay. All right. That is what your type is. There we go. Okay. That is the type. Okay. Okie dokie. Let's run this again. All right. 1. 1. 1. 2. 1 1 1 1 1 1 1 1 1 1 1 1 1. It's not register. It's surprisingly not registering. Maybe it might be because of what we're running it on. It might be what we're running it on. Actually, to be fair, it also might be the fact that our log is probably eating more RAM than it should. Let's get rid of the log. Where are you, log? There you are. Okay. Technically, come on. I'm surprised it's not listening. Listen to me. Come on, listen, Pygate. Alright, maybe I have an idea. Okay, let's exit out. I might have an idea. Maybe we might need to offset this to a different processor. Alright, well, okay, why not this? It's 6:15. I need to, I think we can call it time for coding. We're doing quite well. We're doing quite well. What I'll do is, because we've been working on this for 7 days, almost 7 days now, I'm going to, let's go ahead and save what we've done. So let's do that. So let's see, change Framer to RGBA mode. Let's see here, update sequencer to have alpha background. And then last but not least, update animator to use Pygame. There we go. Okay. So I think that's good. We still have a lot to work on. I'll work on it a bit here and there on my the CVouts, figuring out ways to improve it a bit. But for that now, what we're going to do is we will start another project. Let's go ahead and start that now and get it set up. All right, so yeah, we're going to have this. There's our location. Yeah, we'll create a Git repository. We'll use the new, sure, we'll use this one right here. Create a welcome, we don't need a welcome script. Now let's just, where's the name of the project? I think it'll be right here. Location. This is going to be the, so yeah, this is going to be the, this is a database. That's what I'm going to be building. This is a database. It's going to be a kind of special kind of database. So I guess let's call it what it is. It's going to be a ROM, ROM data helper. There we go. There we go. Okay. Sure, we'll use this window. There we go. All right, so here we have our file. Let's go ahead and create our source. There we go. And then let's also do this. Let's go ahead and create, well, not really create, but let's see here. We'll call this the database. Or let's see here. We'll call this core, maybe? Core. Sure, why not core? Core. Mongo. There we go. So pretty much, let's go. Pretty much what we're going to do here, we're going to install Mongo Engine. There we go. We're going to also install pandas and this. See, that should install NumPy as well. Yeah, that should install Numpy as well. We're also going to... I wonder... Actually, I don't know if this computer... I don't know if this tiny computer actually will have enough memory. But I also want to install... Hugging Face. There we go. Okay. Because the idea of the project... Maybe we should... Let's see here. That's our environment. Why don't we go ahead and start a new... No. Editor config file. No. Maybe just a normal... Just an empty file. All right. We'll call this the... project details. There we go. Okay, yeah, sure, add it to Git. Okay, so what is this project? So this is going to be a ROM checker, sorter, and let's see here. This should be ROM and respective data checker and sorter. Now you might be asking, what does this mean? Well, what this means pretty much is this. I will have a folder of ROMs. In this case, it's going to be old Nintendo games that I ripped. Oh, actually, maybe we shouldn't do Nintendo because Nintendo is sue happy. Oh, if Nintendo sees this, they might go, ooh, we're now going to proceed to sue the crap out of you. Okay, Sega. There you go. Sega ROMs. Sega ROMs. So the idea is that we're going to take ROMs. We're going to use Genesis for this. And we want to check for the, what is it called? The, SHA 32, as well as the CRC. We want to check for these. We also want to check patches for games and the checksums. We also want to check for attached data, which would happen to be pictures. So it'd be pictures, movies, or I should just call it videos. Pictures, videos, icons, flare, you know, these types of things. And then lastly, it should all be, dynamic. As in, the dynamic. And what this pretty much means is works for any folders, or works for any ROM sets, and can be can work for any ROM sets. Ideally, we're going to use MongoDB for data storage. And we're going to be tracking ROM hacks. So one of the very fun things, so this is what the project is going to entail pretty much. So one of the very fun things that I've done, or I should not say I've done, but one of the very fun things out there is if you go to a website called romhacking.net. And let's make sure that we are human. Here we go. So romhacking.net has an awful lot of really fun, really interesting hacks. You have to own, or you have to have access to the data. But if you do, you can go in and you can find a lot of different changes and modifications. For instance, Zombies Ate My Roguelike. Here's somebody who tried to convert Zombie Ate My Neighbors into a roguelike game. You can even see it was inspired by Binding of Isaac. Oh, here we go. We have the database. So here we have no intro. It's the no intro version. I'm going to have to actually see if the version I have. Yeah, because. Yeah, when I came to Hong Kong, I did not have means to bring over my collections. So I ended up spending time ripping all of these. And it's easy for when it comes to things like the PlayStation, for the GameCube, for the Xbox, because there's a lot of different tools available for ripping CDs. Very easy to do those. When it comes to like Nintendo and Genesis, that is so annoying. Oh, let's see here. Let's see here. If I can just show you what one has to do. So what I ended up doing was using a particular device. You can buy these old, you can buy these kind of old card game. Actually, I think that, actually, I can show you an example of one. I know, I don't actually know what the name of the one I used was called, but I know an example of one. So Super Nintendo old game ripping console. Uh, where are you? No, 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 no. Let's see here. I don't see it. I don't see it here. Oh, is it being hidden? It might. Oh, actually, wait. There. No, that's the original Sony one. No. All right, I don't see it. Okay, I don't see it. It's hiding it. Okay, but the main point is there used to be old consoles that you could buy. They're bootleg pretty much. They're old consoles you could buy. But what you were capable of doing was ripping the games to a floppy disk, and then from there you could then proceed to upload the data to your computer to store them. And there have been many other consoles released more recently where you don't have to do that. But for me, I had floppy disks. I had to insert them in, do the data dump, and then that was it. So yeah, I have a couple. Not a huge amount of games because I couldn't buy every single game, but I do have a couple. Oh yeah, there we go. Let's see here. Let's see here. Well, okay, we'll forget about that. We'll forget about that. Thinking about it, if we try and dive deeper, we might get into legally very gray area. The main point is that we have the main point is that there's a lot of these ROM hacks, and what I want to do is I want to track these. I want to track them. I want to, build a database so I can sort through them, and I want to be able to, access the information. For instance, this is for Zombie Ate My Neighbors, and because this is for Zombie Ate My Neighbors, then whenever I look up this hack, Zombie Ate My Roguelike, I should be able to get all of the information about Zombie Ate My Neighbors, and then I should be able to get the patch details, which would technically be the description here, which will explain all of the changes. So there's going to be a lot of data cleaning involved here. And we might actually even have to do some data ripping. In fact, I think we're going to have to be be very friendly to the different websites. Maybe they have a database already, but we're going to have to use Selenium. We need to collect some data somehow. Let's see. Databases. Do you have any databases? I see a dictionary. The ROM, the policy. Ooh, maybe we should check the policy real quick. Screenshot redistribution, abandonware, community, copyright claims, credits. All right then. Oh, here. First and foremost, oh, this is the patcher. Yeah, we don't, that's not what we're interested in. Fonts, games, hacks, all right. Homebrew, links, news, ISO information, restricted consoles and platforms. They're not permitted at this time. Well, these are all brand new games, so or brand new consoles. I can understand. Okay, brand new in a sense that they're last 8 years, but yeah, this is like the almost most recent gen, like last gen. So I can understand why they're restricted. Screen resolutions, all right. There's definitely a lot of information here, but the main information I'm looking for, I don't see it. Do they have it? Do you have a database that I can use? Because I don't want to scrape yet. I see a community database. I see links. Maybe it's in links. Hardware and development. Ooh. Hardware and development. Nope, that's not it. History wiki. Ooh, maybe in the wiki? Yeah, okay, I'm not seeing it anywhere. I'm not seeing it anywhere. We're going to go with the Sega Mega Drive, which is the Genesis. Okay, yeah. All right, so yeah, I don't see a database. So yeah, we're going to have to use Solarium to extract the data. We're going to have to store it in our own personal database, which will be MongoDB. We will have to extract out, store a lot of the different data and do a lot of cross-references between them. But ideally, the goal is that we will be generating this code here so that I can track checksums, track the patches. In fact, I would actually am planning to set it up so that I can download the patches automatically. Download the patches automatically, have a reference to where they're located, like where we got it from. And then also, well, I don't think we can worry about applying it. I can see about if it's capable to apply or not. But the main point is it's just going to be a basic tracking of ROM hacks and tracking of the data that's provided with them. Because when you're creating a customized front end to load up games, you kind of need these things like pictures, videos, icons, flair. You need these. And when you have a very large list of games, it's a bit difficult to keep track of. So yeah, this is what we'll be working on next time. So yeah. Fun. Let's see here. How are things faring? Okay. So yeah, I'm going to hop off now. Everybody have a good one. Tomorrow we'll be having fun with ROM hacking. Until then, laters. Have a good one. Hopefully you don't get rained on. And yeah, see you next time.